And we're recording. Okay, we're actually ready to get started now. Excuse me, if I could ask you to come grab a chair up here. We're about to start our talks for the evening. So, welcome to PDXRust. This evening we have two talks. We have Godfrey on bridging Rust and Ruby, and then we have Jeremiah's talk on RustDoc. Unfortunately, Jeremiah's cat had a medical emergency this afternoon, so I will be going through his slides. Fortunately, the slides are pretty much self-documenting, so you will still get all of his content. The other announcement that I have is that the DevOps Days PDX organizers have offered us a free ticket that I can just raffle off to an attendee. So if you would like a copy of that ticket, or if you would like to have a chance to win that ticket, I will pass around a piece of paper that you can put your name on, and then I'll pick a random number and take the name at that number, and then you get to go to DevOps Days for free. So with that, let's get started with Godfrey's Bridging Rust and Ruby.
Okay. So do you need to see this? My slides. Okay. Unfortunately, we have some technical difficulties, so we have to do a some sort of synchronized dance here. So if the slides get a little bit out of sync, please bear with us. Is one of these things on? Maybe. Technical difficulties. Hello. Hello. How is that? Okay. So I am Godfrey. I work on a few open source technologies such as Ruby on Rails or Ember.js. If you would like to talk about those things, we can chat after. You can find me on the internet as Shenkin Code. Before I begin, I should probably tell you a little bit about myself. I am a professional Go player. A lot of you might not know that, but I just started pretty recently, and I already made it to a pretty high level, so I'm pretty impressed with my progress so far. So as you can see, I'm a professional Go player. So as I mentioned, I'm really excited about this career change that happened recently, because part of it's like I get to do what I love for work, and more importantly, I finally have a reason for going to the gym every day. And that's a picture of me going to the gym. Unfortunately, oh, that's also a pretty old picture, by the way. So I'm currently at, I believe, level 18, not level 7, and that is not one of my strongest Pokemon anymore. Anyway, so this is a pretty cool gig, right? But then it could also be pretty frustrating sometimes. And the most frustrating thing about being a professional Go player is probably this screen. If you have played, you might have seen it, but it basically tells you the server is down, and whenever that happens, like, it's really frustrating. It's like I need to work, but it's like my VPN is not working, and every time it is, I think, like, come on, how difficult is this? Like, this 2016, I thought we figured it out already. Like, you gotta catch them all. Anyway, so that's my day job. And when I'm not catching Pokemon, I work at, my hobby is a software engineer at a local company called Tilder in Portland here. We have a product called Skylight. It's basically a monitoring dashboard for your Rails applications, and it basically gives you advice on how you can improve it. If you use Rails, you should probably sign up here at skylight.io. And as I mentioned, this is basically my hobby, so the only way I get anything out of this is through referral credits. So if you could sign up with that link there, I really appreciate it. Please take out your pen and paper and write that down. Okay. So that's me. But anyway, if you're from the United States Citizenship and Immigration Service, that was a joke. I do work at Tilder as a full-time employee, so please don't take away my visa. Also, if you're from the IRS or the CRA in Canada, please note that Skylight credits have no cash value and they should not be considered a form of income for tax purposes. But anyway, you should sign up even if you don't use Rails. We have a pretty cool insider newsletter. That's one of those newsletters on the right, and we basically just take turns talking about what we're working on at our job, and like the weird problems we ran into, and sometimes it's like Ruby, sometimes it's JavaScript, sometimes like when we're doing Rust, we like basically, I have this really frustrating thing today, and but here's the solution I found, or sometimes we couldn't find a solution, but the next day, like some of our customers on the mailing list I recently ran into that problem, and here's a potential solution. So it's a pretty cool newsletter if you would like to get an insider peek on how we work. So you need to basically sign up with or without the referral link, but once you sign up, you can go into your email preference and change your email preference to the insider channel. So anyway, that's me, and I realize this is a Rust meetup, but today I'm here to talk about Ruby. If you didn't know Ruby is a scripting language, you might have, like I guess some of its closer cousins or things like Python. Right? If you might be more familiar with it, Ruby is basically a scripting language on roughly the same level of abstraction, and has a lot of influence from things like Smalltalk, Perl, and it's a pretty cool scripting language, and I would encourage you to check it out if you haven't played with it. You basically just you can really easily install it, and you can get into an interactive console and start playing with it. So there are a lot of things to love about Ruby. The syntax is very sweet, and it's like really focused on developer productivity and developer happiness. That's what they call it. And the ecosystem is very mature. And for example, if you use Rust, you probably use Cargo, and you're probably familiar with the Cargo ecosystem. So if you work on both Bundler, which is the version of Cargo in Ruby that I guess came before Cargo and heavily influenced Cargo's design, and so you can perhaps extrapolate your Rust ecosystem experience, and there are a lot of awesome libraries, and Ruby is similar. And the community in Ruby is pretty awesome as well. So there are a lot of great things about Ruby. But one of the things that Ruby is not particularly known for is being a fast language. Okay? But in the real world, most of the workload are I/O bound. Right? So this doesn't actually end up mattering all that much. And because I/O operations are so much slower than the speed of computation, the performance difference isn't really a bottleneck for the most part. Especially Ruby is usually used for writing things like web application, and you can imagine most of the things you're actually doing is like reading from the hard drive, talking to database, network, and stuff like that. So even though most of the workload in the sectors that Ruby is typically used for is I/O bound, there are still plenty of CPU bound workload in the world floating around here and there, and you might occasionally encounter them in your app. So for example, you might need to crunch some numbers, you might need to do some machine learning or image processing, video compression, et cetera, et cetera. And sure, we have come a long way with scripting languages, but it's still usually prohibitively expensive to implement these kind of heavy computational algorithms in scripting languages like Ruby. On the other end of the spectrum, there are low-level languages like C. Right, so these are system languages, and they basically have almost none of the features we love about Ruby, but since they're much closer to the metal, so to speak, you'll be able to squeeze out every last drop of performance you need from them usually. And fortunately, you can actually have your cake and eat it too in Ruby. So Ruby has a pretty awesome native extension API, which allows you to implement the expensive part, the computational part of your program in C, but expose them via the same sweet Ruby syntax that we're used to. So to your users, it basically act like exactly like a class or a function implemented in Ruby. You can't tell from the outside, but when you call it, actually calls into C. So for example, again, this is roughly the same story as cargo. When you install a gem, is basically the equivalent of a crate in Rust, right? So if you do gem install JSON, what you're actually getting here, you're actually getting two different things for the price of one. So first of all, included in the bundle is a thing called is a module called json::pure, and that basically implements the JSON encoding and decoding API in pure Ruby, so it works on every platform that Ruby is supported. And however, chances are that you will not actually be using that in practice. If your system supports it, the gem will also compile and install a native extension called json::ext, which basically implements exactly the same API in C. So when you do json.parse in Ruby, basically the first time you load the library, it detects, you will have the native version of the gem. If so, use it. So you load the native version, right? And when you do json.parse, give it a string, it would actually call into C and do the parsing in the much faster native version. So needless to say, the C implementation is much faster than the pure Ruby version, but otherwise there are no noticeable differences to your end user. So this example illustrates why the Ruby C API is so awesome, because as far as your end users can tell, it feels just like programming in Ruby, and they get the benefit in terms of the performance boost without even knowing that that's what's happening under the hood. So I mentioned I work on open source technology called Ruby on Rails. It's a web application framework, and just like Ruby, Rails building on top of Ruby also inherited a lot of the philosophy from Ruby, particularly around programmer happiness. Right? So here's a quote from the creator of Ruby on Rails, and I think I will extrapolate a little bit. Basically, we're willing to jump through a lot of hoops to on the implementation side to make the user-facing API feel nice in Rails, and I think a lot of that spirit is shared by a lot of the Rust libraries or Rust APIs that I have been using so far. So this is one example of the kind of sweet API you find in Ruby. So this is a active support core extension method called string.blank. So here is the implementation, more or less, from some older version. The difference, like if you go to master, the implementation is a little bit different, but for our purpose, it basically doesn't matter. So this method, as you would expect, checks if a given string is blank. So why would you want to do that? So actually, if you're writing web application, a lot of time you want to check if an input field, for example, user input is blank, right? Like if you submit a form, but you didn't put anything in the required field, or you only put white spaces in there, you would want to reject the form and show an error message. So this is one of the most dominant use case, but it's also used for a lot of purpose. And since Ruby allows us to reopen core classes, we can basically just define this method on the string class, so you can do double quote the string, double quote dot blank question mark, and it would work. And you don't have to do any sort of, so it just feels like it's part of the core API, right? It's just a method on the string class. So that's pretty sweet. perhaps because this method is the syntax is so nice and this is so handy, this method is used very extensively in a lot of Rails apps, both in framework code and also in user code. In fact, it's apparently popular enough to be one of the performance bottlenecks. It's not a bottleneck per se, but it's a performance hotspot for a lot of Rails apps. So if I mentioned before, Ruby has a native extension API, so why don't we implement this method in C to make it faster? So that's exactly what this person called Sam Saffron did. He basically made a gem called fastblank. All you need to do is basically add it to a gem file, which is the equivalent of the cargo.toml. So basically, you include this library in your application, and it transparently replaces the Ruby version with a C version. And on micro benchmarks, it could be up to 20 times faster, and apparently in some macro benchmarks, you could see up to 5% improvement on the application side, which is pretty impressive. So now that we have a good way to gracefully speed up pieces of code and fall back to pure Ruby implementation if we need to, if the platform doesn't support it, aren't we done here? Why don't we do this for literally why don't we write Rails in C, basically? Well, there's a problem. The problem is me, the person standing right here. You see, me, Godfrey, the Rails core team member, I don't really consider myself a system programmer. Sure, I have programmed in C before, but I consider myself, I would say I know just enough to be dangerous. For example, if you give me a pointer, I probably would know how to add enough stars to make the compiler happy. If it doesn't work, you can try more stars, and if everything else fails, you can. If everything fails, there's always ampersand as well. But obviously, I'm being a little bit hyperbolic here. But my point is, system programming it's pretty hard, right? I don't mean it's hard to learn. I don't mean the syntax is hard to write, although it is hard to learn and the syntax is hard to write. But what I mean is that it's hard to get right. One small mistake in your code and you could suddenly crash your program at runtime, right? Or worse, you can behave unexpectedly and open wild security vulnerabilities like go-to fails and things like that. And those people are obviously much smarter than I am, and if they can't get it right, I have mega doubts that I want to spend my free time writing C code that ships in a lot of people's applications and take responsibility for that. So basically, at the end of the day, you can do it. You have the C API. It's available to you. But at the end of the day, the trade-off is, is the performance gain really worth the risk, right? As a person working on Rails, not being paid to do it in my day job, am I really going to take the risk and do that? Or even though, let's say I am willing to take the risk and do it, am I really able to find, am I going to be able to find other contributors in the Ruby ecosystem, like the scripting language ecosystem, to help people, to find people to help me maintain the C code that I write? So I mentioned I work at a company that makes a product called Skylight, and once upon a time at Skylight we had to face the same trade-off here. So Skylight is a performance monitoring tool for Rails applications. So we have an agent that we embed in people's Rails apps, and we collect basically performance information at runtime, and we send them back to our server. So we aggregate them and show you a dashboard to highlight the performance problems in your apps. So the first version of the Skylight agent was written in Ruby. So that was the natural choice, so to speak, because we need to hook into Rails to collect those performance data points. So writing it in Ruby is the natural thing to do here. So that solution lasted us a while, but very soon we started running into performance problems and memory issues. So we were able to keep it more or less under control, but as we look into adding more advanced performance features like tracking the number of allocations or maybe even CPU profiling, the performance penalty of doing these things in Ruby is getting prohibitively expensive, and sometimes like there's even no API for you to do it in pure Ruby. So the answer for this problem has always been obvious. Like we are a performance monitoring thing, so we obviously care about performance, and we can't slow down your code. So we should just do the right thing and write our own code as a native extension for our customers. But the same question from before remained, right? Even though our engineers do understand the difference between a reference, the reference and the reference operator, do we really feel comfortable putting our C code in our customer's production application, right? One small mistake, you could crash the app, or you could be responsible for some crazy thing like remote code execution vulnerabilities. And do we really trust ourselves enough to do that? Can we afford the risk? And let's say we ship that code, will everyone on our team be able to work on the code at the same pace as before and keep shipping new features? So the question is, could there be an alternative to C or C++ that basically gives us the best of both worlds? And I think since you're here, most of you are probably familiar with Rust, but in case you're not, that Rust is the answer to that question that we have. So if you go to the website, Rust is a system programming language that runs blazingly fast, blah, blah, blah. So that's a lot of buzzwords, but I think for me it basically boils down to a few things, and this actually is taken from one of the I think it's probably from the Rust 1.0 blog post, but the key features for me is first, there's memory safety with a garbage collector. So just like C, Rust is a compiled statically typed statically typed language, and so before your code is executed, in case you're coming from a Ruby or Python background, you basically have to run your code through the compiler, which do a lot of checks for you and basically checks for a large amount of programming error. And instead of allowing them to bubble up at runtime, basically just refuse to compile your code and like, please fix this before you can, before we'll make that work. And unlike C, Rust has a sufficiently advanced type system and a carefully designed feature set to allow the compiler basically guarantee runtime memory safety. So in other words, if you write safe code in Rust and your program compiles, it basically is guaranteed to not segfault at runtime. So that's pretty cool. The other thing is concurrency, which I won't really get into today, but so the safety aspect is nice, but the coolest meta feature to me is the idea of zero cost abstraction, which is a slogan you might have heard from other talks or Rust blog posts before. But the idea is basically in high-level language like Ruby, there's often a tension between writing or using high-level abstractions and performance. So for example, it would be nice if you could break up a large function, a method, into smaller pieces, like smaller methods. But method calls aren't free, right? So in very hard paths, you have to make the decision of, do I really want to incur the extra cost of a method call and move this out, or do I just want to take the hit on readability and just inline everything here myself? And there are also high-level things like functional transform, like .each or .map iterators and such. But they're also they're also slower than a carefully handcrafted loop, even if you write it in pure Ruby, right? Because method calls and such. So most of the time it doesn't matter. Like I said, most of the time you're bound on I/O anyway, so you can do whatever you want. But in hot paths, you basically have to make the trade-off. And in Rust, the idea is you don't generally have to make these kind of trade-offs. As compiled language, the Rust compiler is basically able to use all the type information that I mentioned from the previous slide to deeply analyze your code and basically do those kind of optimization for you instead of you trying to do it by hand. So you can basically just organize your code for maintainability, and the compiler would do the work to optimize that for you, and you don't pay the cost at runtime. So in fact, sometimes the Rust compiler can produce faster code when you use these high-level constructs. For example, when you use an iterator in Rust, the Rust compiler can see that what is the Rust compiler can see into the intent of your code instead, as opposed to writing a loop in Rust, right? So if you use iterators in Rust, the Rust compiler is actually able to eliminate the bounds check because it is in control of doing the loop instead of you doing whatever. So that actually produces more optimized code compared to carefully handcrafting a loop in Rust. So that's the general idea, and if you would like to learn more about Rust, we did a talk at RailsConf 2015 that goes into more details. But okay, let's go back to fastBlank, which is, if you still remember, the native extension for making the Rails string.blank method faster by writing it C. So here is the implementation in C. You probably can't read it, but don't worry, I'll walk through that with you. So this is basically a header. If you're not familiar with C, it's basically declaring a function called ABSTRACTIONS. So this is basically declaring a function called ABSTRACTIONS, and the value after static is the return type, and the value inside the parentheses is the type of the argument. And as you can see, in the Ruby C API, basically everything, every Ruby object has this type of value, which is actually type def to a void pointer. So we will come back to this, but one of the problems with operating at the Ruby C API level is all you get. I forgot to mention, in Ruby everything is an object. So a string is an object, a number is an object. It's not necessarily implemented like that under the hood, but there's some smart things, like sometimes you notice the integer is small enough, you can just put it in the pointer instead of instead of actually allocating an object. But conceptually, everything in Ruby is an object, and therefore in the C API level, everything you take and return is basically this value type, which is a void pointer. So unfortunately, this means not that the C compiler is generally good at this, but because everything is a void pointer, the C compiler basically have no ability to do any sort of check for you, and you would have to remember to do the check yourself at runtime. Otherwise, if you think you're getting a string in the value pointer, but it's actually a number for some reason, then things would go horribly wrong in your extension. It would probably segfault or do something really strange. So that's the header of the function, and there's some boilerplate at the top. But then the next thing is basically immediately it calls a macro called rstring length, and if the string is empty, like if the length of the string is 0, it immediately returns true because an empty string is a blank string, right? So this is one of the things I'm talking about. So rstring length, obviously, that only works if you pass a Ruby string to it. If you try to pass a Ruby object or try to pass a number, it will probably try to do some offset from that pointer and look into some weird memory location and returns a complete, like maybe a negative number, who knows, right? So this is the kind of dangerous things you need to be thinking about. You need to be really sure that this function is getting a Ruby string as input. Otherwise, this line right here could probably segfault your C extension, and the compiler can't warn you about that because as far as the compiler can tell, everything is a void pointer. So then the guts of the program is basically a while loop And because all the strings in Ruby is UTF-8 strings based, actually that's not true, but in practice most of the Ruby strings you're dealing with, and here we're implicitly making an assumption that this is a Unicode UTF-8 string. So as you know, UTF-8 characters not necessarily fixed length in terms of bytes, so you cannot just do a for loop and increment the pointer. So this is why this is a while loop, and you have to go through some other macros to check whether you're at the end of the string. And then there's some more boilerplate, and then there's basically a switch statement, and in the guts of the switch statement is basically an enumeration of all the known Unicode white space characters. So basically, if you saw a white space character, you can continue to the next iteration of the loop. Otherwise, you return false immediately. So you saw a non-white space character, so the string is not blank. And then finally, if you got to the end of the string and all you have seen are white space characters, then you can return true, because that means your string is blank. So this is the implementation of the C version of the blank method. So all in all, this is around 50 lines of code and C for, so writing 50 lines of code for 20 times speed up, it's actually, I think that's a pretty fair deal, and I think that's actually, even though there are a lot of boilerplate and stuff, that's actually not so bad. So let's try to implement this same function in Rust. So yes, that is it. So basically, we'll first convert the Ruby string into a slice type in Rust, and then we call the chars method on it to get an iterator of other characters in the Unicode string. So keep in mind that we're talking about Unicode string, so that is not necessarily a trivial thing, but Rust takes care of that for us. And then we call the .all method, which takes a thing that looks roughly like a closure, and you're basically saying for each character in the string, check if the character is a white space character. And is white space is also a standard library function in Rust that basically takes care of the hand enumerated list of white space characters for you. So in case Unicode decide to add more white space characters, you are good here. You have to recompile your program, but you don't have to maintain the list yourself. So actually, if you still remember the Ruby version, I skipped a bunch of highlights, sorry. But basically, this is pretty straightforward. So, so let's see how they compare. So surprisingly, this one-liner thing in Rust, it's pretty fast. It's basically in the same ballpark as the C version. The numbers here are iterations per second, so like how many operations you can do per second roughly. And as you can see, they are both very fast, and they're much faster than the Ruby version, and it's roughly the same performance as the C thing. So so that's great, but I have a confession to make. I have not been completely honest with you. While the Rust one-liner is much shorter than the C version, that's not all the code you need to write the native extension. So to make it work, you have to write plenty of glue code both in the C and the Rust version. So let's take a look. The highlighted portions, so on the left is the Rust, the full body of the Rust native extension, and on the right, that's the C version. The highlighted version is what I've shown you on the slides, in the previous slides. And the not highlighted version is the code I didn't show you. On the C side, you can see it, even though the actual implementation is very long, the boilerplate is it's pretty minimal. And on the Rust side, you can see that even though the actual implementation is very short, the boilerplate basically add up to the same amount of code as the C thing. So this is not all bad news. Like for one thing, we turned to Rust because we wanted speed and safety. So if we got both of them, and that is achievable with the same amount of code, that's still a win. But furthermore, if you think about it, the highlighted portion, as I said, is the implementation of the extension, right? So that's the actual logic that you're trying to write. So you have to write that code every single time you want to write a method, because that's what your method trying to do, right? On the other hand, the boilerplate is mostly code that can be shared across extension. You just have to write the same kind of, like, not exactly the same lines of boilerplate, but you roughly write the same kind of boilerplate for each extension, and they can be shared. So if the glue code is shareable, wouldn't it be great if someone did the work to extract them into the library? And I'm very glad you asked, because that's what Yehuda and I have been working on. We have been working on this thing called Helix. Yehuda is there, by the way. He is on the Rust core team. You can talk to him afterwards. But Helix is basically a language bridge between Rust and Ruby. So currently we're focused on implementing Ruby code in Rust, right? So implementing Ruby classes in Rust. But so we're not super focused on embedding Ruby from the Rust side yet, but eventually the code is probably shareable for both purposes. But for now, this is about embedding Rust code, like Rust native extension, inside Ruby. So let's look at how you would implement fast blank with Helix. And this time, I promise this is all the code, right? So thanks to Rust macro system, we were able to abstract away most of the verbosity and distill it down to the parts that you actually care about. In the syntax, that should be pretty familiar to Rubyist. And we should thank Dave Herman for paving the way. He worked on a thing called Neon, which is the V8 binding for Rust, and we were able to steal a lot of these macros from him. I guess I will quickly walk through this, although I'm running out of time. So basically, we have a declare types macro, and then inside there we say reopen class Ruby string, and then we define a method. And this is roughly the same syntax you would use in Ruby. And inside here, finally, this is the one-liner we saw on the screen earlier. So the implementation to boilerplate ratio here is pretty small, and pretty happy about that. And so we talked about how in the Ruby's API everything is a void pointer, basically. And this is problematic because we, like, with that kind of API, we are very easily we can very easily write code that was segfault. So the cool thing about Helix here is because the Rust type system is so much more expressive, we can actually implicitly encode all of the types guarantee that's not actually found in the original Ruby API into the Rust type system. So if you actually say that you take a string, what we will do is we'll generate the we'll take an unchecked value, and then we'll generate, like Helix here, will generate the code that do the runtime check to confirm that it's actually a string, and then if it's not a string, it will throw a Ruby runtime error to the user, like pretty much what they're used to, right? Like if you call a method with the wrong argument, you would get a runtime argument error, which you can rescue and stuff. But we basically won't hand the value to your code if it doesn't match the type you expected, which is pretty cool. And you basically get all of that for free with using these macros. And I'm going to skip ahead. So part of the plan is, I guess I plan to do some more stuff, and like now that we have this set up, we can do some more Rails features. Like we can experiment with doing some more Rails features in Rust, and that would be pretty cool. And you can also write some of your, like the number crunching part of your app in Rust. That would be pretty cool as well. I actually have an example which I won't have time to go into today. But I actually wrote a blog post about this. If you Google introducing Helix, you will find the full blog post with this. So I think I'm just going to jump to the very end here.
Cool graph comparing your timing.
Okay, we will talk about, although I didn't actually tell you what the code is, but you can see, as you can see, I've made a graph, and the Rust thing is much faster, so you know it's like you see a graph, so you know it's legit. Anyway, so here is the GitHub repo for this, and again, you can Google introducing Helix, and you'll find a blog post with more information. So finally, I would like to wrap up with this. Unsurprisingly, scripting languages like Ruby are intrinsically slower than system languages like C or Rust. And historically, scripting languages were really designed to be used as a coordination layer between, and they usually delegate to the heavier tools like that's written in system languages. So for example, you might write a bash script that delegates to the Unix utility like sort and grep and WC. Those are all written in system languages like C. So you're basically not doing a lot in your scripting layer historically, and they're just basically coordinating the heavier tools. But as I mentioned before, because a lot of the real-world workload actually turned out to be outbound, pure performance is not always very important, and because scripting languages tend to be a lot more pleasant to use and they're easy to iterate on and so on, we end up moving a lot more of our code into the scripting layer instead of writing everything in system languages. And since web applications are especially I/O heavy, that worked out great for things like Ruby and Rails. But I think we're now entering an era where programming languages implementers have taken more and more of the ergonomics side of things from scripting languages and starting to add those features back to performance-critical languages like Rust. Right? So our goal with the Helix project is let people from the Ruby community to keep writing the Ruby that they're used to and love, and without fearing that eventually they will hit a performance wall. So with Helix, you can always start with your Ruby app, and whenever you realize you have, and you will always know that you have the option to move certain parts of your code to Rust if you feel the need to do it, instead of rewriting your entire app in something like Go. So in my opinion, Rust is particularly suited for this task, for especially for Ruby teams, and thanks to the strong guarantees of the Rust compiler and the strong focus on abstractions, I think a lot of your team members will be able to basically tinker and iterate on the Rust part of your code base much more easily compared to something like C and C++. And the worst thing that could happen is that your program doesn't compile and you know you did something wrong. So that's basically, I'll start with Helix, and this is a very, very early preview of Helix, and there's still plenty of work to do, and we're just working on it this weekend, actually. And we have a lot more interesting problems that I don't have time to cover here, but yeah, I think the future for this kind of stuff is pretty bright, and it's pretty cool that Rust is enabling us to do these kind of cool things. So I think that is it for my talk, and we can chat more afterwards.
We can take one or two questions now if anybody has. Yeah. Just for the recording, that how does Helix come into play with Bundler, and how do you publish gem?
So that is a good question. So I can tell you, we're not quite that far with Helix yet, but we do actually ship our Skylight. So Skylight has been, the Skylight gem, the Skylight agent has been written in Rust for probably coming to 2 years or something like that. So we've been shipping that to customers' apps for a long time. And the way we do it, it's really dependent on the scenario of your deployment, right? So if you're, for example, if you're rewriting a part of your app in Rust, then you pretty much control everything. You probably control your CI